Hello, this is Ms. DB. In this video, we are going to talk about graphs of linear equations. Our objective today is to graph lines with given equations and sets of points, and to determine if an equation is linear or nonlinear. So lines can be given as graphs, tables, or equations. Let's look at some examples of linear equations. If you are given a graph, you want to make sure that you have a straight line with no curves and no turns. So both of these are linear equations. If you're given a table, you want to look at the differences. So first check the x variables. From 6, we'll work from the bottom. 6 minus 4 is 2, and 4 minus 2 is also 2. So the differences are the same. Now let's check the y variables, and we'll start at the bottom again. 7 minus 5 is 2. 5 minus 3 is also 2. So the differences are the same for the x variables and for the y variables. All right, let's look at the second table. We'll start at the bottom. 2 minus 1 is 1. 1 minus 0 is 1. So the x values have the same difference. Now let's look at the y values. 8 minus 6 is 2. 6 minus 4 is 2. So the y values have a difference of 2. They have a constant difference, and that means that these are going to be linear. We can also graph these points, plot these points on a coordinate plane, and if they lie on the same line, if you can connect them and make a straight line with no turns and no curves, then you know that they are a linear equation. Finally, we can look over here at the equations. The x and y variables, they'll usually be both, should not have any exponent except 1, which we usually don't write, so we can't have squared or to the third power or anything. And we can't have any variables in the denominator. So if there's a fraction, it can only be a number in the denominator. And you can graph these using technology, or you can graph them using some skills like using slope and y-intercept that we'll learn later. And if you graph these and you form a straight line, then you know that this is a linear equation. So everything on this page is a linear equation. Let's look at some non-examples. Here are some that are nonlinear. That means they do not form a straight line. If we graph them, we can see that there might be some turns. This is nonlinear. Or maybe even two different parts of the graph, and they also have a turn. So both of these are nonlinear. In our table, let's look at the differences again. So we check the x variables. These will have the same difference. 4 minus 6 is 2. 4 minus 2 is 2. But when we go to check the y differences, 36 minus 16 is 20. And 16 minus 4 is 12. Those are not the same number, so they don't have a constant same difference. So this is an example of nonlinear. Let's look at the next one. If we check the x differences, 2 minus 1 is 1, 1 minus 0 is 1, 0 minus negative 1 is 1, 0 minus negative 1. 0 minus negative 1 is the same as 0 plus 1. So that's also a difference of 1. And negative 1 minus a negative 2 is a difference of 1. So that's fine. But then we move over to the y values, and 5 minus 2 is 3. 2 minus 1 is 1. So already we can tell that they do not have the same difference. I could keep going. 1 minus 2 is negative 1. And 2 minus 5 is negative 3. So they're all different. They're not constant. So these are not going to lie on the same line. We can also graph them using technology like Desmos. And if they do not lie on the same line, we'll know that these are not, this is an example of a nonlinear. Finally, we'll look at some equations. In the first one, we have an exponent on the x variable. You can't have an exponent besides 1, so because it's x to the second power, right there we know that that's nonlinear. In the second one, we have a variable in the denominator, and that also is non-linear. All right, next up, we're going to look at a problem from your worksheet. The directions on the worksheet say to name whether each equation, table, or graph below will be linear or nonlinear. So you will write linear or nonlinear. So here's our first problem. It says y equals x squared minus 2x. You should be doing this on your worksheet along with the video. So there's two ways to tell. Method 1, look for exponents on the variables. If there are any besides 1, then this is nonlinear. Well, we have an exponent on the variable. So right there, we have enough information to know what this is. But maybe you want to check or just do method 2. Then we can use technology such as Desmos. So this is the website to Desmos. You can just type in desmos.com as well and then click on Graphing Calculator. And then we'll check it. So let's open up Desmos and see what that would look like, how we would graph that. So this is what Desmos looks like. And over here is where you will type this exact equation. Y equals x. Now how do I make x squared? There's two ways. On your keyboard, you can push Shift and the 6 key to get this little up arrow key, which makes an exponent like this. Or you can pull up the Desmos keyboard at the bottom and then click on the a squared button, a to the second power, which gives this the exponent of 2. And then I'll type the rest, which was minus 2x. I can see from the graph that this is not a straight line. So either from graphing or from looking at the exponents, I can tell that this is a non-linear equation. So then we would write non-linear for answer for number 1. So do that on your worksheet, pause the video, and when you're done with it, start the video up again and we'll look at another problem. Okay, here's the solution to number 1. We can tell from both ways that we have a non-linear. This is non-linear, both from the exponent and from the graph. All right, let's try another problem. This one is not number 2, this is number 3 on the worksheet, and we are given a table. So to check and see if a table is linear or non-linear, we can do method 1, look for a pattern in the x and y variables. If both increase or decrease by the same amount, it is linear. Or we can use technology again and plot these points. So if we want to check the differences or check if they're increasing or decreasing, we check the x variables and they're all increasing by 1. And the y values are all also increasing by 1. So from 4 to 5 is 1, from 5 to 6 is 1. So that means that this is linear. But we can also check with Desmos. Let's look at how to do this in Desmos. How do we plot points in Desmos? There's two ways. One way is just to enter each point separately. And to do that, you can put coordinate points have parentheses around them. So put a parentheses from your keyboard or from down here, there's a parentheses. And then type 1, 4, and then close your parentheses. And that point will be plotted on the graph. And then we can do that for our other 2 points. Oops. And then there's one more, 3, 6. The other way to do these points in Desmos is to use a table. So click on the plus sign and then on the table. And then here we can enter them just like they look over here. 1, 4, 2, 5, 3, 6. And look at these lines are all going to, if we were to draw a line through them, we would see that that would be in a straight line all going through those points. We can even connect our points by clicking on the edit list, this little gear that lets you edit things. And then we can select the black dot, which we could change to another color if we wanted to, and then selecting the lines button. and now it'll connect the points. But it only connects from one point to the next. It doesn't go through the points like we really would like it to. If we wanted to really draw a line through here, we would need the equation of this line, which we'll work on in the next folder. But we can see that these, either with method 1 or method 2, we can see this is definitely an example of a linear equation. So for number 3, you would write linear for a solution. So now, if you haven't done number 3 along with me, pause the video and complete this one as well. All right, now I want you to finish on your own 2, 4, 5, and 6 from your worksheet. So just pause this video while you answer linear or nonlinear for each of these questions. Linear or nonlinear for the rest of this part. And when you're done, start the video up again. All right, so now you have finished up through number 6 on the video, on the worksheet, and now we're going to look at graphing points in a linear equation. So we're going to be given some tables that are linear. So for the rest of the worksheet, assume they are linear. We will plot the points in the table on a coordinate plane and then draw a straight line through them to graph. You have 2 options. You can plot them in Desmos and add links to your graphs, or you can print the worksheet and then plot by hand. There's really a third option too, and that is to use the Word tools, the drawing tools in Word to do that. But that would be the same basically as drawing by hand. Remember to draw a line through the points after plotting them. The line should continue through the points and extend beyond them in both directions, not start and stop at your points. Let's look at a couple problems from your worksheet. Here's number 7. We're going to graph this one by hand. So I am given an equation and some points that would be from that equation. So these points have already been calculated for you and put into a table, and now we are going to plot those points on a graph. So the first point, x is 1 and y is 4. So on the coordinate plane, you go over 1 on the x-axis, and then up 4, 1, 2, 3, 4, and you put a point there. And we did the first one. Now we're going to do the point 2, 5. So on the x-axis, you go over 2 and up 5, and then you put a point. So we did the second one. The next one is 3, 6, so you go over 3 on the x-axis and then up 6. And then we got that one done. And there's one more, 4, 7. So go over 4 and up 7. Oh, I almost went too high. And then put a point. Now remember, these are examples of linear equations. So if you got a point that does not look like it fits in the line, then you made a mistake and you need to go back and check if you plotted one of the points wrong. I think I can use a ruler to draw this. I'm trying to spin my ruler, but I don't know how. Spin, ruler, spin. Whoops, I turned the page. Okay, I'm trying to spin my ruler so that I can use this to, no, that's okay. If you have a ruler, you can use it, but you want to now draw a straight line through these points and extending beyond in both directions. So you don't want to just a little piece of a short line like that. You want your line to go through to the edge of the graph in both directions, like this. And there's a line that would go through those points. So do number 7 if you want to try this one by hand. Otherwise, you can wait a minute and I'll show you how to use Desmos for these. All right, let's try this one using Desmos. So this is number 8, and it says y equals 2x, and then we're given these points. So you could graph it by hand, but for this one, we're going to practice using Desmos. So here's my Desmos. And I'm going to make a table of these values. So I'm going to click the plus sign and table, and then I'll enter in these values. So x is -2, y is -4. And then you can just hit enter to get a new row and type -1, -2. And you can see the points appearing down here. And then 0, 0 is the next point. That's the origin. And then 1, 2. So I see now that the points have been plotted, but there isn't a line appearing. One way to graph the line that goes through those points is to type in this equation in another row in line 2 here in Desmos. So y equals 2x. And I want to see if all the points that I had earlier entered in will be on the line, and you can see that they are. So now you have two options on how to share your work for your worksheet. Option 1 is to use this share graph button. If you click on it, you will get a link and you can paste that onto your worksheet. And that link will take me, when I check your work, directly to that graph that you just made. So there's the link to this, to the one I just made. Your second option is, while you're in Desmos, to take a screenshot or a snip of this. So I'm going to use something that's in Microsoft computers called Snip and Sketch, and I'm going to take a snip of my graph. So I just draw a box around the part that I want, and then I click on copy, and I'm just going to come over to my worksheet, pretend this is my worksheet, and Control V will paste that onto my worksheet. Control V. So that's another way that you can share your work, is paste, take a snip, and then share it on your worksheet. Paste it onto your worksheet. All right, so next up, you get to finish your worksheet. So try either method 1, drawing by hand, plotting the points and connecting them with a line, or try method 2 using Desmos. You have 4 left to do: 9, 10, 11, and 12. And go back to rewind the video a bit if you need to see how to do these again. All right, hopefully you have finished all of the problems on your worksheet. If you get stuck, you can rewatch the video, or you can come to my office hours or go to the ASC room for help. Thank you very much and have a wonderful day.